Hello everyone, welcome to my channel. So in today's video we are going to see how we can implement WebSocket using AWS API Gateway. I'm going with the assumption that you know what is a WebSocket connection and what are the advantages of it. So we will straight away look into how we can implement WebSockets using API Gateway. Okay. So these are all the topics that we are going to discuss in this series of videos under this topic. So in today's video we are going to see how we can create a simple chat application using API Gateway WebSocket. So this is not going to be an end-to-end chat application, rather just the backend portion of it, like how do we utilize WebSockets. We will not have any front end for this as such. And in the next lecture we will talk about what are some of the major important metrics that you have to monitor related to API Gateway as well as Lambdas. And in the third lecture we are going to cover some of the AWS limits that you have to know before you roll out your code into production. And the last lecture will be on some of the best practices and anything else that I might miss out in the first three lectures. Alright, so let's get started with our first topic today, like how can we create a simple chat application with API Gateway WebSockets. So this is how our application would look like. So pardon me for coming up with such a lousy diagram, but I thought I should just give you a high-level overview, and then I would like to spend more time in coding actually. So as you can see, we will have we have to come up with these 3 or 4 lambdas that you see on the right of the screen, that a connect lambda, a join lambda, a publish lambda, and a disconnect lambda. And our backend would be a DynamoDB, so we will save all the records into the DynamoDB database. These are all the various WebSocket routes that you see on to your left. There would be a connect route, a join route, a publish, and a disconnect route. If you think of this, right, like for example, let's say you're creating a WhatsApp group, okay? So first time when you create a group, you would want to join a channel, correct? Join the group. And then when you send a message, which is publish, you want that message to be sent to everyone else in that group, right? And then when you disconnect, that is when you exit the group, everyone else, either they can be notified or you can silently come out of it. So that's the kind of parallel on what we are trying to build here using WebSockets. Okay. Now let's get into the coding portion of it. So I have already written the code for the lambdas. I'm going to walk you through like all the various steps that you have to know about while you come up with the lambdas. This is a simple Maven project here that we have. So these are some of the core dependencies that you have to import. SDK core. This is AWS SDK API Gateway Management API. This is required because you want to like talk to the clients, like post data to the connections, etc. Post some messages to the connections or manage the connections. So this is why you need it. And the DynamoDB dependency is of course to save data into the DynamoDB. And these are the Lambda Java events. This is basically whenever API Gateway calls a Lambda function, you want to capture those events, right? So that is why you need this dependency. And this is also for the Lambdas. And the last few dependencies are for logging. All right. Now let's check the first one, which is the connect lambda. Okay. So what this lambda is doing is it's pretty simple. So if you can see, it implements this interface request handler, and this is the API Gateway WebSocket event, and this is the API Gateway WebSocket response. So this is the request and this is the response that it is returning. So as you can see, this is the handle request method which you're overriding, and see the request type. This matches with what you have in here, API Gateway WebSocket event. And the response that you're giving back is nothing but what you've defined here, API Gateway v2 WebSocket response. So connect Lambda is pretty simple. You're not really doing anything. You're just logging what is the connection ID associated with the WebSocket connection. So connection ID is nothing but, think of it like a primary key in a database. Like every connection would have a unique connection ID. So this would help us in like managing the connections. Like if you want to send out a message to a connection, you would use this connection ID to push a message to the client. You're not really doing anything here. You're just setting up a response with a status code of 200, which means it's all good, that you're successfully returning back a response. So there's nothing much going on in here. So this is our first Lambda, connect Lambda, right? So if you go back to the diagram here, this is our connect Lambda. So first user connects to an API gateway, then we would invoke this connect Lambda. So don't worry about what's really going on with all the Lambdas and how they're tied up to the API gateway. I'll walk you through all the steps in setting up the API gateway and integrating them with the Lambdas. For now, we are just going through the Lambda code for the various Lambdas that we have. The second one that we have is the default Lambda. This is basically if the route doesn't match to any of the existing ones, it would fall back onto the default Lambda. Again, there's nothing much here. You're just setting up a response status code of 200 and you're returning back a response. This is again a similar, pretty similar to connect Lambda. It implements the request handler interface. This is from the Lambda runtime if you see, and the request and response is API Gateway WebSocket event and WebSocket response. So in our case, for the disconnect Lambda, we are going to actually use the default Lambda itself. I'll tell you why, and it's not ideal for a production scenario, but I'll tell you what can be done. Okay. The next one is join Lambda. So this is like you are joining a WhatsApp group, like something like that. Like so, you're trying to join a channel. So what you're doing here is that, and what is it that you receive here? Like what is it the client sending you? He's sending you two items, like what is the channel ID, like which channel do you want to join, and what is the route associated. So this route would be, this route would be used by the API gateway to route the traffic to the appropriate Lambda. This is the channel ID. So what you're doing in the channel Lambda is basically you get the connection ID, you get the channel, and you save them into a database. So I'll explain you on how the database table would look like, or maybe I can show it to you right now. So if you go to DynamoDB and let's go check the tables. So this is this table. This is a pretty simple table. You have the table name is channel connections, and it has only two fields basically. One is the channel ID. This is what is the channel ID and who are all the connections that are in that channel. In this case, if you see under channel 1, you have 4 different connections. So think of it like there are 4 different users who are in that channel. And similarly, we have another channel called test, and it has like 3 different connections tied up to that channel. So this is a pretty simple table. That's all to it. There's nothing more. So in this Lambda, what you're really doing is you're just saving that record of channel ID and the connection ID. You're just tying them up together into the channel connections table. That's the join channel. And if you want to look into the DynamoDB code of it, right? So as you can see, you're just creating a map of channel ID and connection ID, and then you're creating an item. So in DynamoDB, you call them as items, and then you save the item to the table. So it's table.put item. It's pretty simple. So let me know if I'm skipping over these items too fast, because my intention is not to get into the Lambda code or the DynamoDB code, but if you feel like you would need more explanation into this DynamoDB code or either the Lambda code, I'm happy to come up with another video and explain in detail. Okay. So yeah, that's the join channel Lambda. Again, it's the same interface. It's implementing the same interface as the connect Lambda and the default Lambda. So once after you save it to the DynamoDB table, like the channel ID and connection ID, you are returning back a response of 200. Okay. And the final Lambda that we have today is the published Lambda. So this is like, now you are in a group, your friend is also in the same group, and now you want to post a message to everyone else in the group. So you would call this published Lambda. So what this published Lambda would do is, let's see what is the payload that it is taking. So it's taking a route. This route is used by the API gateway to call the appropriate Lambda. I'll explain more about this route. Channel ID is nothing but, okay, to which channel do you want to publish the data to, and what is the data that you want to publish. So basically, if you send this input, it would take this data and it would publish the data to all the users who are tied up to this channel. Okay. And how is that done? So what you're doing in here is, first you're getting all the channel connections associated with that channel ID. This is again a DynamoDB call, but it's pretty simple. So you're just querying by the channel ID. So you're retrieving all the connections associated with this channel ID, and then you're returning back a list. So once you have the list here, you're looping through that. You loop through that connection IDs, and then you push data to that connection. So this is important because this is how you actually push a data to a WebSocket connection for an API gateway. So you create this request, create this object called post to connection request. If you post to connection request, and this is, if you want to see which jar it is in, this is our API Gateway Management API jar. It's part of this one. You construct this request object with a connection ID and what is the data that you want to send it or push to that connection. So this data is nothing but whatever data that you received from the clients. I'm just calling it push data. It's a pretty simple one. It just has a string data in it. So you're converting that into JSON and then you're pushing it out to this particular connection. So post to connection request, and then you have this API async. So this is nothing but, so you are using AWS client builder class. You have the endpoint configuration here. So this is hard coded. Ideally this would be system dot get env. This is the Lambda environment variable, and then so what you're trying to do here is you're trying to first get, okay, to which API gateway is this connection associated with. So you're constructing this API async using this API gateway URL. with the standard configuration. So how does Lambda have the privileges to push it to API Gateway? I'll explain you that within the next few minutes. So you create this endpoint configuration, and using this endpoint configuration, you create this API Gateway Management API Async object using a standard builder, and then with endpoint configuration, whatever you built it here, you're building it. And this is in the US West 2 region. It can be any region, it's up to you, but in my case, this is in the US West 2 region. And this API Gateway URL, if you want, you can just hard code it if your API Gateway is already in there. If not, you can ideally, this should be an environment variable. But so that way, even if your API Gateway changes, you just have to update your environment variable. So you construct this API Gateway Management API Async, and then using this object here, you just say post to connection and pass this post to connection request object. So this would post whatever data that you want to send to that particular connection associated with this connection ID. So what you're doing here is you're looping through all the connection IDs associated with the channel, and then you're just pushing out the data to it. Okay. Once we look at the whole flow, I think we can come back to this again, and then you'll have a much better understanding of what we are trying to do. Okay. So I hope you understood the lambdas that we have here. So we have the connect lambda, where you just establish a connection. You're not really doing much here. You're just printing out the connection ID, and then you're returning a response. Similarly, default lambda, you're not doing much. You just return a 200 response. A join lambda is you just saving the channel ID and connection to the DynamoDB. And when you come to the publish lambda, you're retrieving all the connections associated with the channel, and then you're pushing out publishing the data to those connection IDs using the API Gateway SDK. All right. Now, what would the next step that you would do here is basically you would do a Maven clean package, and then you would generate a jar with all the dependencies in it. So you can see I've generated this jar with all the dependencies here. So this would, and then once you build this jar, you can do a Maven clean package, and then you should be able to build this jar. And once this jar is ready, now let's see how our lambdas are designed. Okay, let's go to lambdas. So as you can see, I have these 4 lambdas here. Let's look into one of them. So how you can do is you can just say upload, and then you would point to this jar, and then you just click upload here, or open in this case. So that would upload your code, and then it would build this connect lambda here. Okay. My runtime is Java 11, and then in the handler you're specifying which lambda. So within the jar, right, we have 4 lambdas, correct? But in this case, this particular lambda is the connect lambda. So you are referring to that connect lambda here. You give the whole path including the package name, and then you specify what is the method name, that is handle request here. And in the configuration, you don't have much going on except one important item, that is the lambda role. So what is this lambda role? Let's see. So if you look into the permissions, right, so you're giving lambda the permission to post to a connection, and this is required an EC2 full access, and API Gateway access as well, because you're talking to API Gateway. DynamoDB access, because you're saving and retrieving data from DynamoDB. And CloudWatch access, because you would be pushing out logs to the CloudWatch. So you would create a role with all these permissions. You don't have to give full access. You can restrict it to a minimum, like depending on what operations that you're performing, but just to keep it simple, I gave complete access here. So you give all these permissions to the role, and then you would assign that role, execution role, to the Lambda. So then now Lambda has all the privileges to either to talk to API Gateway or to talk to the DynamoDB. Without these privileges, if you try to run it, it would fail with errors either to connect to the API Gateway or to connect to the DynamoDB. Alright, so in a similar fashion, you would consider other Lambdas as well. But for the published Lambda, let me show you the configuration here. So in the configuration, if you look into the environment variables, so here is where you would specify the API Gateway URL. So if you remember the code, if you go to the published Lambda here, at the beginning, you are trying to first get the environment variable of the API Gateway URL. So it would retrieve the API Gateway URL, whatever you specify here, and then it would, when it is trying to post a connection, this connection is tied up to this API gate, this particular API Gateway API. Okay. Now let's go to API Gateway, and then let's create one for the WebSockets. So as you can see, this is what you would click on: WebSocket API. Click on build. Let's give some name to it. My WebSocket API, and then route selection expression. So don't worry about it. So for now, just go with what you have here. Request.body.action. I'll tell you what this is in detail in the next few minutes. Click on next. And now, so by default, as you can see, you have some routes defined here. The connect route, here is the description of what it is doing. So this is the route triggered when a client connects to your API. So this is the first route that gets triggered. Disconnect route is when either the server or the client, if they close the connection, then the disconnect route is triggered. And the default route would be triggered if the route that you pass in your message, if that does not match with any of the routes, then the default route would be triggered. And we can add custom routes as well. So now let's add custom routes for two of our Lambdas here, join and publish, right? Because we have a connect route, we have a disconnect route, but we don't have routes for join and publish, right? So let's add our route for join, and let's add another route for publish. Okay. Next. In here, what you're trying to do is you're trying to attach a Lambda with each of the routes. So you're saying that your integration type is Lambda, and you're coming up with like a connect. This is the Lambda function that you have created there. This is for join route. Okay. Let's go back one step and see if so add connect route, add disconnect route, add default route. Sorry, I forgot to add this. So, and now you go to the next one. So now for the connect route, you want to add an integration. Integration in our case is a Lambda integration. So what you're saying is when a connect route is called, you want to invoke this Lambda called connect Lambda. And when disconnect is called, you want to invoke just for the sake of this example, I'm calling default Lambda. Ideally, you want to come up with a disconnect Lambda, and then that disconnect Lambda should basically remove the connection from the DynamoDB table, like all the associated channels and channels for that connection. You want it, basically it's a cleanup after a connection is disconnected. But in our case, we're just sending it to the default Lambda. You're not doing the cleanup, so don't do this in your production code. And for the default one, you're again going to the default Lambda. And for the join one, you want to select the join channel Lambda. And for publish, you want to select the publish Lambda, right? Click on next. This is the stage name. So as you can see, stages are independently configurable environments. So if you have, you can come up with as many stages as you want. I think there is a limit of, I think 10, I don't remember exactly, but so in our case, I'm just giving it a name called production. It can be any name here. So you add a stage, click on next, and then just say create and deploy. So you can see our API gateway is now set up, it is ready. So these are all the routes that we have: connect, disconnect, join, publish, and default, right? So the ones that we have here, I did not specify default here, but that is also one of the routes. And now in stages is our production stage here. When you click on this one, you would see few important items here. One, what is the URL that the clients have to use to connect to our WebSocket? And this is another important one. So you have to copy this URL here, connection URL. So this is to manage your connections basically. And if you go back to the Lambda, right? Let's go back to the Lambda here. And let's go to the published Lambda. If you remember the environment variables, we specified the API gateway URL here, right? This is from my old API gateway, since we've come up with a new one here which has a different URL that starts with NT. So let's update this one. You have to remove the add connections at the end. You just have to leave the stage here and then save. Yeah, so this is the URL that the clients would use to connect, and this is the URL that our Lambdas would use to push data to the connections. So there are some other settings here, like some throttling limits, which I will discuss in the next lectures. But yeah, so basically that's about it. Like if you want to just get started, so you have all the routes, you have your stage, you have your URL. Now let's see how this works. Okay, now let's go to terminal here, and then so I've tried this. So what you can do is you can download this thing called WSCAT. It's a easy way to establish WebSocket connections. So if you just Google for WSCAT, and then if you install it, you can just do whatever I'm doing here. So the command that you want to give here is WSCAT -c, and then this is the URL. You want to go back here and copy this URL that you have here, Command C, and then paste. See, now it got connected. So now let's see what has happened. Okay, now if you go into CloudWatch, and then you go to log groups, and if you go to connect here, and then you check here, you should see, so see this log here, it says WebSocket connection ID is this one. So this is nothing but what we have in our code here in the connect Lambda. So you're specifying here WebSocket connection ID. So if you go back to API Gateway, right? So now what has happened is, when a user first tries to establish a connection like this using WSCAT, he tried to connect, right? Now the connect route got invoked automatically because that's the first route that will be invoked. The connect route got invoked, and then as you can see, this connect route is calling our connect lambda here. This is the initial integration that you have set up. The connect lambda got invoked, and within the connect lambda you just printed this line, and then you return back a 200 response, right? Now it is a success. Now let's see what do you have to do next. Now you want to join a channel, right? So for the join channel, if you look into the request, how it look like, it should have two fields. One is what is the route in our case, and what is the channel ID, correct? So route would be join, because you want to join a channel, right? How you would do that is action join and channel ID, let's give it test1. okay, so what is this action here? It looks weird, right? So if you go back to the API Gateway here, see the route selection expression here. This is request.body.action. So instead of this, you can specify something else as well. But whatever you specify here, like instead of action, if you just give route maybe, then what you have to do here is, instead of action, you would say route colon join. That is the significance of this field call action. So now you join this channel here, and then this is the channel ID. Now what do you want to do next? Next you want to publish some data to the channel, right? You go back here and then see, okay, what is the route for publish? It's nothing but publish. If you click on every route, you would see which lambda it is calling. So when someone sends a message on the publish route, that request would be sent to this lambda, publish lambda. And what is the data? So now when you go to publish here and then check the publish object, pretty simple. It should have a route which will be used by the API Gateway. What is the channel ID that you want to publish data to, and what is the data that you want to publish, right? So this is how our it will look like. First thing is action. As you know, it would be publish. Next thing is channel ID, which is nothing but test1. And what is the data that you want to publish? Let's just say hi. Okay. Now let's see what has happened here. Ideally we should have received that hi here, but okay, we got it. I mean, in a production case scenario, you don't want this message to come back to the same user who has published it. You would ideally filter out this particular connection ID, and then you would want to send it to everyone else in the group. But since this is just for demo purpose, even this user who published the message also received that message as well. Now let's create another user, and then let's see if he receives that message or not. Okay, so it's again WSCAT -c, and then you want to get the URL, right? So now go back to the stage here, copy this URL and paste. So this guy is also connected. Now so the same process. Now he wants to join a channel, so he would specify the channel ID as I think we gave it test1, right? right? Test one. So you go to test one, and then he joined the channel. Now he wants to do a publish again, so he would give action as publish. Channel ID would be test one, and data would be hey, I am user 2. Okay, so as you expected, this guy received the message. Let's see if the other guy also received the message or not. See here, so hey, I'm user 2. Now if this guy sends a message, let's see if the user 2 receives it or not as well. So it will be the same thing again. You want to publish, specify the same channel ID again, test one, and what's your data? Your data is hi user 2, I am user 1. Okay, so let's see if the second user got this message or not. As you can see, so now you understood the whole flow, right? Like, so this is like you're chatting with someone else. So you established a WebSocket connection, the user 1 also established a WebSocket connection, and that channel is left open, and as you are typing messages, it's going on the channel, so it's bidirectional, so you can send messages and you can receive messages on the same channel. There is no overhead of establishing a HTTP connection every time you want to send out a message. So the channel is kept open, and then you would receive the messages. But does this channel, will it be open? Will it always be open indefinitely? No, it won't be. So in case of API Gateway WebSockets, so the maximum idle connection timeout is 10 minutes. So what it means is that if you leave the channel open and if you're not sending any messages on it, that channel would get disconnected within 10 minutes. And then when it gets disconnected, right, this is what you would see. Disconnected with a code of 1001 going up. This basically means it got disconnected because it is idle. I'll get into the status code, etc. in the later videos. But yeah, so that is one limitation, like the idle connection timeout. And the second thing is, what is the maximum time for which a channel can be open? For API Gateway, the maximum time limitation is 2 hours. So that means if the channel is not idle, like if you're constantly sending messages, even then the maximum time a channel can be open is only for 2 hours. It cannot live for more than 2 hours. It will get disconnected at that 2-hour period. It would be disconnected by the API Gateway. You would get a different status code then. So now next question is, how can you keep the channel open, right? Like, user may or may not send messages for 2 hours, right? So the solution for that would be, you just have to, clients can keep sending some sort of ping message to the server, just to keep, so whenever a client sends a ping message, the server can respond back something like a dummy message for it. As long as you have this constant pings for maybe every 10 seconds or 30 seconds or 1 minute, depending on the firewall settings of the clients or your whatever, right? So pick some number, and then as long as you have these ping messages going across the channel both the ways, your channel would be open for that maximum duration of 2 hours. So yeah, that's pretty much it. And then if you want to look into the logs, right, you can, or let's check in DynamoDB to see if we got a new channel, right? See this one here. So we have test one channel which we just created, and it has 2 connections. that you have. These are the two connections that you established in the two tabs in the terminal that we just saw. So that's pretty much it for this video. Let me know if you have any questions, or if you feel like there is if there is any information that I left out, or if I went through too fast. I'm happy to cover it in my further videos. So as I mentioned earlier, in the next video, let's look into what are the various metrics that you want to monitor. Some of the API Gateway metrics, as well as the Lambda metrics that you have to keep in mind when you roll this out to production. So in this video, we are going to talk about some of the important metrics that we need to look into for the API Gateway WebSockets, and also some of the limits that are imposed by the API Gateway. But before we get in, let me do a quick recap of what we have discussed in the last video, so that you can easily connect to some of the other items that I'm gonna talk about in this video. So let's go back to AWS here. So as you can see, we have the API Gateway, and these are all the various routes that we have. Connect route, disconnect, join is to actually join to a channel. So think of it like a Slack. Okay, so if you guys have used Slack or any other messaging platform, basically, so you join a channel, your friend also joins a channel, and then when you publish a message, it's like you're chatting with your friend, right? So when you publish a message, the message would be posted to your friend, and vice versa. When your friend posts a message, you will receive it, because both of you have joined this particular channel. So in our case, so this is how we define our action, or this is how we select our route key. And the connect route is actually a Lambda proxy, which is talking to the connect Lambda. For now, I did not implement disconnect route. Join route calls the join channel Lambda, and the publish route calls the publish Lambda, right? And then we have the default route. Just to see a quick recap of how this works. So let me kill this and then start a new connection here. So now you're connected, right? So after you connect, what you're doing next is you're trying to join a channel, right? As you can see, action is join. So why did we give the action as join? That is because you see request.body.action. So this action needs join. So when this matches, the join channel Lambda would be invoked. So now this user has joined the channel called test. Now in another tab, we have another user who is already connected to the join to the same test channel, right? Now let's see what happens if this guy posts a message. So in order to post a message, what we need to do is, again, action needs to be publish. So why is it publish? Now go back here. We have a publish route. So if a user calls the publish route, publish Lambda would be invoked, and then this Lambda will actually send your data to all the users who are connected to that particular channel. So now when this guy sends publish here, so it would work something like this. Like he would see this guy received a message called hi, and then even this guy received another message called hi. So just to change the message, just say hello, and then you post it. So even this guy receiving, we can suppress this, so we can only send it to the other users in the group, but I did not do that just for the sake of this demo. So as you can see, this user received a hello as well. So this is how WebSockets work. So you open a channel between two users and they can communicate with one another over that WebSocket channel, right? So this is a quick recap of what we did in our last video. So going back to the presentation here again. So in this video, we are going to talk about some of the important metrics and limits for the API Gateway WebSockets. Okay. So first, let's talk about the metrics. So what are some of the important metrics that we need to look into? So these are the ones: the connection count, message count, integration errors, execution errors, and client errors. So where can you see these metrics? If you go back to the API Gateway here, and then if you go to the dashboard, you should see all the metrics in here. So let's go through one by one. So what is connection count here? So if you want a detail or a description of it, so AWS documentation has it. So basically, connect count is nothing but the number of messages sent to the connect route integration. So what this means is that how many requests did this route actually receive? So if we go back to our example here, if this user has sent, so when you type this command here to connect to the WebSocket API Gateway WebSocket, this is considered as 1, and the connect count is increased by 1. Similarly, if another user connects to it, the connect count would be then 2. So it basically tells how many requests have you received in a given time interval. So what you need to be careful is that with API Gateway WebSockets, you cannot really tell at a given point of time how many users are actually connected. Unfortunately, AWS doesn't provide that metric. It would have been really helpful, because with whatever metrics that we have currently or what you see on this board, you cannot tell how many users are connected. You can only tell how many users have connected in a given time interval. That's all you can tell. In this minute or in this second, how many users have connected. That's all this connect count metric tells you. Okay. And now the message count. So what is message count here? So once after a user connects to a WebSocket channel, then he actually starts posting messages, right? As you can see, user has posted a message here, and he posted another message here. So every message that the user posts is actually a message. It comes under the message count. So that is this other metric here. So I mean, as you can imagine, usually the message count would be way higher than the connection count, because once the users are connected, they start talking over the WebSocket channel. So the message count is usually higher than the connection count. Next one is the integration latency. So what is integration latency? This is the time difference between API Gateway sending the request to the integration, in our case it is the Lambda, and API Gateway receiving the response from the integration. So what this means is how much time did the Lambda take to respond back, and for the API Gateway to receive that response. So the overall latency. Next metric, in this case, if you see, it is, for example, I think here it says 3000 milliseconds. So basically it's 3 seconds. Next one is the execution errors. So what are execution errors? So errors that occurred when calling the integration. In this case, you're trying to call a Lambda, but for some reason it failed. So that will be counted as execution errors. Next one is integration error. Integration errors is the number of requests that return a 400 or a 500 response from the integration. This means when you call a Lambda function, and if your Lambda function returns a 400 or a 500, maybe because you sent in a bad data, you would get back a 400 from the Lambda, for example. Or there is some error, maybe it failed to talk to DynamoDB or some other data store, and then it threw a 500, your Lambda threw a 500. So all those would get translated as your integration errors. And client errors is nothing but the number of requests that have a 400 response returned by API gateway itself, even before the integration is invoked. To be honest, I haven't really run into the client error, but my guess would be there is something wrong with your input payload in itself. So I think if something like that were to happen, then I think you would get a client error instead. So these are some of the important metrics that you need to monitor, especially the ones. There's one more thing, so let me explain that as well, and then I'll come back to this again. So when you look into your API gateway here, and then you click on stage, so you would see there is some default throttling that has been set. Your current account level throttling is 10,000 messages per second with a burst of 5,000 messages. So what is really this messages per second? So if you look into the AWS documentation, you cannot find this anywhere. This is not mentioned anywhere, like what is messages per second. But what this actually means is that it is nothing but a request per second. That is basically your message count per second plus your connection count per second. The overall is the request per second or messages per second. So that is the default limit that they have set, which is 10,000. For a production environment, usually this is really less. So when you're rolling out your WebSockets into production, what I recommend is estimate your usage and then work with AWS support to bump this limit. So depending on your usage patterns, I think AWS support can easily increase this limit for you. So to understand this better, in this case, let's say the message count is 60 or 120 per second, okay, or 100 per second, and your connection count is, let's say, 10 per second. So your overall messages per second is 100 per second plus 10 per second, which is 110 per second basically. So that's how it's roughly, that is what it would translate to, the sum of these two in a second. So you have to be really careful, because if you forget to bump this metric in production, and if your traffic increases, then as you can see, it would start throttling automatically. So how does throttling work basically? So I'll share this link as well. So as you can see here, since 10,000 is the limit, if a caller submits 10,000 requests in 1 second period evenly, for example 10 requests every millisecond, then API gateway will process everything. But if some caller sends 10,000 requests in first millisecond itself, then what would API gateway do? It would serve 5,000 of those requests. What is this 5,000? Where is this coming from, right? So that is the burst capacity. So that means all of a sudden, if 5,000 messages come in, that is the maximum that it can process. Anything about 5,000, it would throttle all of them. So whenever you see the request being throttled, right, I think API gateway will give you back a 429 too many request error. So in your client code, you should possibly, you would probably notice this 429 appearing, too many requests. So you can go through this document in detail to understand the API gateway limits. But the important point, as I said, is estimate your usage and then leave some buffer on how many messages that you might want to process. For example, let's say you are expecting your messages to be maybe 50,000 messages, right? Then you would talk to AWS and then you would set the limit at, say, maybe 75,000 messages per second or something like that. So that is one important metric that you need to consider. You would not find much documentation around this metric. And the other thing, the interesting thing is, when you first roll out your API gateway to production, my recommendation is you enable the CloudWatch Logs and then you put it in info mode. and then you log the full message data, and you also enable access logging. So you can define your own log destination here. So why I recommend putting it in info mode is because this will give you a detailed logging message on when was the connection established and why was the connection, so what are all the messages exchanged and why was it disconnected, so on and so forth. So in case if you see any issues on your if your client sees any issues, then you can easily check your logs. If you put it in error mode, it won't really log much information for you to debug. It's from my experience, it's not really helpful, the error logging at this point. So till you feel comfortable with your code in production, I would say keep it in info mode, and once you figure out all your issues and errors, then go back to error, because if you leave it in info mode, it's gonna cost you a ton of money just for the CloudWatch logs in itself. So definitely look into the CloudWatch logs when you first roll out. The reason why this is important is, let's say your WebSocket connection was closed for whatever reason, right? So now you need to find out why was it closed. Did the client close it? Did the server close it? Because if your client closes the connection, I think there is something called a disconnect status code which gets logged into the CloudWatch. So that would be -1 if the client has closed it. But if the server has closed the connection, I think it would be something else. I think it's 1001, or I guess it is 1001. So these codes really tell you who closed the connection. And if you see any issues, you would have to reach out to the AWS support, and then you would want to present them with these logs saying, hey, these are the logs that I see and these are the disconnect status codes. So when you provide them with those logs, then they can really help you out in figuring out if you're running into any issues, right? So yeah, I think that's pretty much about the API Gateway metrics and limits that you want to look into. So bump up your requests per second or the messages per second limit depending on your usage, and also keep a close eye on your logs to see if you're running into any issues after you roll out your WebSockets. And I think the other important item is, so if you ever notice any issues with the Lambdas, right? For example, in this case, our integration is Lambda, and for whatever reason, maybe you hit limits with your Lambda. So all those Lambda throttling, they would get translated into, I think, execution errors for you, because you're not able to call the integration, right? Because Lambda started throttling because you sent too many messages. So that would get translated into execution errors. So my recommendation is to put some sort of alerting mechanism on, like a CloudWatch alert on all the various errors, so that whenever you run into issue like Lambda being throttled or something else, or maybe your Lambda has issues talking to your backend data store or whatever, then you would get errors, and then you would be alerted based on those errors. And another alert that I would recommend is a custom metric, which you might want to, or at least something that would alert the message count in itself. So if you have something on the message count, then whenever you're reaching that default limit or your account limit provided by AWS, then you will be notified, and then you can proactively bump up the limit. So that is and just to recap another important item, this is not related to metrics, but I want to point this out because this is really critical. So with your API gateway, once you establish a WebSocket connection, right? Let's say you don't send any messages, you just connect it. So what do you think would happen? So what would happen is, if your connection is idle for, I think, a maximum of 10 minutes, API Gateway will automatically disconnect that WebSocket connection. So in order to keep your connection and the maximum duration that a WebSocket connection can be open with API Gateway is, I think, 2 hours. So if you want to keep your connection open for a maximum of 2 hours, then what I would recommend is let the clients send a ping message like for every 10 seconds or 15 seconds continuously to the server. So it would be something like this. It would be action ping, and then it doesn't have to be any message. Just send a message to the API Gateway, and then let the API Gateway respond back with some dummy message like say hi, right? So when you keep these pings going in from client to server and server back to the client, your connection will not be idle and it won't be disconnected by API Gateway. And it's not just API Gateway which can disconnect the connection here. So even on the client side itself, if let's say if there are some firewalls configured, so even they can disconnect a WebSocket connection if they notice that connection is idle for a few seconds. So you have to keep a close eye or monitor your clients and see what would be the best possible interval to set that pings going in from client to server. Maybe it is 10 seconds or maybe it is 30 seconds. So that is something that is really important to keep your WebSocket connection alive, so that your connections are not dropped frequently and then reconnecting back again. So yeah, that is my last point, guys. That is all I have for this video. In the next video, we are going to talk about what are some of the limitations for the Lambda function with respect to API Gateway. This is also really critical because any issues with Lambdas, they would get translated or they would be pushed up to the API Gateway WebSockets as well. So in the next video, we'll look into the Lambda limits and also some of the best practices that you can follow when you're working with API Gateway WebSockets. All right. So that's all I have. Hope you guys like this video. Please let me know if you have any questions or concerns. And if you like the video, please do share, subscribe.